Hello guys, I'm Aman Shastri. Welcome to the second video on the most excellent Arduino tutorial series. Last video we saw how to control an LED through the most excellent Arduino Uno. Today we'll be introducing a push button into the mix. So what a push button is basically a momentary switch, right? We press the push button, it can send a 1 signal. We leave the push button, it sends a 0 signal, right? Now if you see, the leads which are bent towards each other are actually connected. So when I press it, a current is going to flow from this lead to this lead, right? Now without further ado, without saying all of that, let us go into making a simple circuit through which we can code an LED using a push button. Alright, here we go. We're going to start off by placing our push button right in the middle. Now note that I'm placing all the both the bent leads on one side of the bridge to avoid any unnecessary connections, right? Now next what we're going to do is we're going to provide power to our switch. How we're going to do that is, first of all, we are going to get our 5 volt and ground rails from the Arduino right there to the positive power rail, and the ground, run a wire from ground to the negative rail. Alright, we got our power rail set. Now let's provide power to this switch, right? One wire would go from the positive terminal to one terminal of the switch, right? And the other wire, the other side of the switch is going to be connected to ground through a resistor. Always remember, through a resistor. If you directly connect it using one of these wires, it's going to create a short circuit and it's not pretty. Okay, anyways, with all that said, now here's how the thing's going to work, right? Current's going to flow from the positive terminal to the switch, and only when we press the switch, it's going to flow back to the negative terminal or the ground. Now, like I said, this rail where the ground is connected and this rail is connected. So all what we can do is we can place a wire over here and attach it to any other Arduino pin to provide a signal. That this will tell the Arduino that when we press the switch, a 1 signal is going to be sent to any digital pin in the Arduino. I have connected it to pin 11 on my Arduino. Alright, that finishes the switch part of the circuit. Now let's move on into making the LED circuit. The LED circuit is always same as before. What we're going to do is we're going to hook up the LED and put the positive terminal on this side, on my left, and we're going to take a pull down resistor of 220 ohm, right? And through that 220 ohm resistor, we are going to connect it to any one digital pin. I am going to connect it to pin 8, and the other lead, that's the negative rail, goes to ground. Alright guys, that completes our circuit. Let's move on to coding this thing. So here's what we are going to do. What our goal is when we push the push button, we want the LED to turn on. When we leave it, the LED is going to turn off. That's that simple. Right, now since we used 2 pins on the Arduino, 2 digital pins, we'll need 2 variables, right? Plus another variable. So we'll need 3 variables. I'll tell you what they are shortly. So we're going to declare one variable int switch underscore pin. Again, always better to have descriptive names. Equals, let's see, which pin have we connected our switch to? We have connected our switch to pin 11. Okay, next, int LED pin, the pin we have connected our LED to. That's the pin through which we'll be controlling our LED, and I have connected that pin 8. Lastly, we'll need another pin, or a variable rather, int val. This is going to store whether the switch reads a 0 or a 1 when the push button is pressed. So we're going to store that data in the variable val. We'll initialize it as 0. That is it. Those are the only 3 variables we need. Now coming to the void setup, we need to set 2 pins. We need to tell the Arduino which of these 2 pins, pin 11 and pin 8, are going to be inputs and outputs. Right? So let's start by doing that. Pin mode. Right? Let's start with our LED pin. LED pin, and as seen in the previous tutorial, we're going to be writing to the LED pin. So we need to make the LED pin an output, right? Next, we need to take care of our switch pin. So let's go ahead and introduce another pin mode switch pin. Now here's the thing, we're going to be reading from the switch pin. We're going to be detecting whether a 1 is sent or a 0 is sent from the push button. In other words, if we press the push button or release it. So we need to make this an input, exactly, an input. And that is it for our void setup. Now coming to the void loop, right? What we need to do is we need to store the data which is read in from pin 11 into the variable val, and that's exactly what we're going to do starting with it. Val equals digital read. We're going to read the value and from which pin? From switch pin, exactly, switch pin, and then we're going to store that into the variable val. Alright, that's cool. Now this will either return a 0 or a 1. If the push button is pressed, it will return a 1. If it's released, a 0. Now all we need to do is we need to check if it's a 1. And if it's a 1, what do we need to do? Exactly, we need to turn on the LED. So we're going to execute a simple if statement. We're going to say if val equals 1, not the double equal to, but it's read as equal to, right? This is to check if any variable is equal to another value in an if statement. Anyway, with that said, moving on. If the value is 1, what we are going to do is we are going to turn on the LED. How do we do that? We do a digital write. What pin do we need to use? We need to use the LED pin. What value are we writing? High value, which is turning the LED on if a 1 is read from the switch. What if we release the switch? Else, right, if the switch is not on, right, that is if we have released the switch, it's returning a 0. We write a low to it, to the LED pin. Digital write LED pin low. That is it. That finishes the coding. So let's go ahead, plug in our Arduino and upload it. Alright, let's see. Let's hope this works. Now note that only when I press this button, the LED turns on a nice white color. And I let go, it turns off. On, off, on, off. So that's amazing. We can read values from switches onto digital pins. Now let's step up the game. I have an assignment for you. Now note that only when I press down on the switch does the LED turn on. When I leave it, however, the LED turns off. What I need you to do is whenever we press the button once, let's say the LED is off and we press it, the LED should turn on, and even after we release it, the LED needs to stay on until we press it again. If the LED is on and then we press it again, the LED needs to turn off. So that is your assignment. Go on, try it, pause the video and try it with all your might. It involves a bit of logic, so you can do it. Okay, assuming that you have had a go, here is the solution to the problem. The circuit stays the same. The only thing that's going to change is in the code. So here's what we're going to do, right? What we're going to do is we're going to declare another variable, a current state variable, and this is going to be a boolean. I've declared it as an int, but we can declare it as a high or low. That's equivalent to saying 1 or 0. Let's initialize it to a low value. Now, what the idea behind this logic is each time a 1 is detected, instead of writing a high value, instead of completely turning on the LED, we just need to change the state, right? Instead of a high, write a low. Instead of a low, write a high. Each time a 1 is detected. That is all we are going to do. There's nothing which is going to change in the void setup. We still need those pin modes. We still need those outputs and inputs. Now what we are going to do in the loop is we still read the digital value. We still do a digital read on the switch pin. We need to detect if it's a 1 or a 0, right? The only thing that's going to change is over here. If val equals 1, instead of writing a high value to the LED pin, we are going to flip the value of this current state. So all we are going to do is we are going to say current underscore state equals the not of current underscore state. And if that doesn't make sense, here's what's happening, right? Current state is currently set to low. On passing it through the not command, it gets converted into a high. And if current state is high, set to high, it will be converted into a low value, right? So we're starting off with a low value. So current state equals not of current state, that just converts the current state into a high value only if 1 is pressed, right? Otherwise we don't need to do anything. Happy life. Current state equals current state. We don't need to do anything to current state. So yeah, current state equals type properly current state. Okay, Now finally all we gotta do is do a digital write to the LED pin of the current state. So I'm going to walk you through the code step by step again. What's going to happen is it's going to the push button is going to detect, the Arduino is going to detect if the push button is pressed, right? And if it is pressed, right, it's going to change the current state. Each time the button is pressed, it's going to change the state, and it continuously be writing the state which it was updated to this LED. So that is as simple as it is. Let's go ahead and upload this code. Ooh, don't forget your semicolon. This is C++, people. We need semicolons. And alright, seem happy with that. Let's go ahead and try this. I'm going to push the press button once. Press the push button once, excuse me, and the LED turns on. Press it again, and the LED turns off. Sometimes my push button's a bit wonky. Turn on. There we go. Turn off. It's a bit wonky. Yeah, anyways, that worked. So we get the idea. Right, now moving on to the second part of the video. How can we control the brightness of our LEDs? Right, we can control the brightness of the LEDs. Now notice that we place a resistor. Right, this is what controls the brightness of the LEDs. Had I put a higher value resistor, say 500 ohm or 1k ohm, this LED would have glown dimmer. It will not be as bright as it is. If I put a lower value resistor, more current is going to flow through it. Right, from Ohm's law, V equals IR. Right, so that means the LED is going to glow brighter. 220 ohms is optimal resistance to to use for the LED. But if you want to control its brightness, we need to use a variable resistor called a potentiometer. I'm going to show it over here to get a better view. Right, so how the potentiometer works is it has three leads. Let me just go ahead and grab a wire to show you guys. Yeah, so we have three leads. Now two of these leads are the positive and negative terminals. Right, this is how you provide power to the potentiometer. You can connect any one of these terminals to positive, any one of these terminals to negative. This lead, however, is the golden lead. This is a special lead. Right, this is going to connect to one of our Arduino pins. I'll specify which one. There's a specific set of Arduino pins you connect it to, and that is how we're going to determine what values to write to the LED. That's going to change the brightness of this LED. Alright, without having said that, let us go into building this circuit. We need the LED to stay the same. We, however, do not need a switch pin and this wire or this resistor. So let's go ahead and take all of these things out, and let's put in our potentiometer. All it is a variable resistor, guys, at the end of the day. Alright, now I'm just going to pop it in like that between the bridges again, so that no unnecessary connections are formed. Oops, the lead bent. We don't want that. There we go. Okay, that seems quite good. Yeah, so now what we're going to do is we're going to connect each terminal over here to the positive and negative terminals. It doesn't matter which side goes to which terminal, as long as they're different. One has to go to the positive terminal, the other has to go to the negative terminal. Else you'll either get no power or it'll be shorted, and it's not pretty again. Alright, so let's connect the left hand side to the positive terminal and the right hand side to the negative terminal, just like so. Right, and for this you do not need any resistor because the potentiometer itself is a resistor. Alright, now the third pin, right, is going to go to an analog pin, A0. That's very important. Analog pins, what do? You can read analog values. You can read values from 0 to 1023. You can read varying values. So as I rotate the potentiometer, different values will be read from this pin A0. That is the idea. Now the Arduino, I should say, has a 10-bit analog to digital to analog, I should say, converter. That means, right, what is 2 to the power 10? In binary you can have two values, 0 or 1. So what is 2 to the power 10? It's 1024. You can read a total of 1024 different values on the Arduino. So we just went from two values, binary, 0 or 1, using these digital pins, to 1024 values. That is such a hike in the range. So we can read a lot more values using these analog pins. Okay, now coming to our LED, we do need to make slight changes. The only change we are going to make is we are going to connect the pin to any set of particular pins. If you can see, certain digital pins, 3, 5, 6, 9, 10, 11, they have a squiggly line, and if you can see over here, the squiggly line signifies something called as PWM. That PWM stands for pulse width modulation. And if that doesn't make sense, all that is that means it can write an analog signal just like these pins. The thing is, these analog pins are meant mostly for reading values, right, rather than writing values, which is why we are going to send the potentiometer to connection to analog pin A0. However, the LED pin is going to be connected to any one of these pulse width modulation pins, the pins which have a squiggly line on it. I'm going to just connect it to pin 10. Alright, pin 10 looks good. Okay, and that completes the circuit. Let's just make sure we have all the connections set. Positive, negative. Again, be very careful with these connections, especially the positive and negative. Make sure you're connected to the right rails. We've connected the analog pin to A0. We have provided power to our whole circuit, and we have connected our LED. Alright, sounds like we're good to go. Let's go ahead and code this thing. Alright, now we're going to start from scratch. So just take out everything, yeah. Now there are a new set of commands which we will need to learn for controlling the LED's brightness. Before that, let's start declaring our variables. Again, we need two variables because we have used two pins on the Arduino. We have used pin 10 this time for our LED. That's right, pin 10. Yeah. So int LED pin equals 10, and now we have connected a potentiometer to analog pin A0. So again, we can say int for this. I'm going to call it pot pin for potentiometer pin equals A0. Now technically this is not considered to be an integer in most languages, but because this is Arduino, A0 is considered to be an integer. It refers to this pin, the particular address of the pin. Having said that, in the void setup, we need to set up our pin modes. Now over here, we only need to set up the pin mode for our LED pin 10. We do not need to set up for A0 because it's an analog pin we're referring to. It's default taken as an input. So pin mode LED pin, and since we're writing to it, output, and that just finished the void setup. We do not need to do anything for the pot pin because it's default and input. Alright, now coming to the void loop. Oh, by the way, we need one more variable here. Have you guessed it? Yes, we need a value to store all the data that the potentiometer sends to analog pin A0. So int while, let's start by initializing it to 0. Now what we're going to do is, like I said, we're going to store all the data sent by the potentiometer into A0 in this variable val. So val equals, now how do we do that? There's a new command called an analog read. What pin are we going to read from? Pot pin. So this is going to this command analog read is going to provide a range of values from 0 to 1024 depending on where we rotate the potentiometer to. Okay. Now this is opposed to digital read. When you do a digital read, right, you can read either a 0 or a 1, fully on or fully off. But when you do an analog read, you can read 1024 different values from 0 to 1023. Alright, let's move on. Val equals analog read pot pin. Now what are we going to do? We are simply going to write that value we get. Analog write, right? We're going to write the same value to the LED pin. That's it. So say we get, I don't know, 512, which is the midpoint between 0 and 1023. The LED will grow to half its brightness value. Say we do a 1023, full brightness value, 0, no brightness. That is what we're going to do. So analog write LED pin. Now notice that unlike digital write, there is no high or low because it's a specific value we're going to write. And what is that value? Well, that is val. Get the spelling right. And analog write LED pin val, and that is just the code for this. Let's go ahead and upload this to the Arduino. Fingers crossed. Alright, there we go. It seems to be at full brightness at this point, but now if I turn the potentiometer, can you see if the brightness is increasing? I can make off over here. and fully increases. Reduce, increase. Can you capture that? Reduce, increase. Sweet. Now there's a periodic increase and decrease depending on where you are in the potentiometer. So yeah, that's just it. Alright guys, that ends up today's session for us. We learned a lot today, controlling switches, controlling potentiometers. I hope you had a lot of fun, and I will see you next time. Thank you.